Question 2a. Carl, Dara, Eche and Fleur are a group of secondary students available to work on a project. For task A, 2 students are needed. One will be researching, the other drawing graphs. List all 12 possible arrangements for the tasks, being specific. So research is the top line, graphs underneath. So we could have C with D, C with E, C with F, or it could be D doing the research with C, D with E, D with F, or E each time with the others, C, D and F, or F with the others, C, D and E. There we have our 12 possible arrangements listed out in a systematic way. Part 2. The number of arrangements can be found using the permutation formula. State the value of n and k. Well, we are looking for 2 roles from 4 people. So this is like n is 4 and k is 2. 4 people and we've got 2 roles. The order matters. So using the formula, 4 factorial over 4 minus 2 factorial gives us 4 factorial over 2 factorial with the calculator, 4, toolbox, enter, move it across, divide it by 2, toolbox, enter. That's what we want, 12. There's our 12. Part 3. Calculate the probability that chosen at random Dara is researching. So researching for Dara is those 3. So it is 3 out of the 12, which we know is a quarter, so 0.25. Eche is not researching. Well, Eche is researching in those 3, not anywhere else. So it's 12. Take away those 3 is 9. So it's going to be 9 out of 12 where she is not researching. 9 out of 12, that's 3 quarters, 0.75. Part 3. What's the probability that chosen at random out of 12, Fleur contributes to task A? Right, when is Fleur involved? 1, 2, 3, 4, 5, 6. So 6 times out of 12, which is a half, so 0.5. B. In a different classroom, 7 secondary students are available for a project. Tess and 6 others, which we're going to call student 1, 2, 3, 4, 5 and 6. For task B, a team with 2 roles is needed. One student organises the lab, the other takes measurements. List all the teams that include Tess. So Tess could be the lab person and the measurement person could be student 1, student 2, student 3, student 4, student 5 or student 6. Or it could be that Tess is the person doing the measuring because she's involved in this team, and then student 1, student 2, student 3, student 4, student 5 and student 6. Here we have 12 possible teams that Tess is involved in. Number 2, use the formula. Here it is again, the permutation formula. What's the total number of all possible arrangements? Well, it's like in the question above. Here we're going to have the same formula. We've got 2 roles from 7 people. So n is 7 and k is 2. We have 7 factorial over 7 minus 2 factorial, 7 factorial over 5 factorial, 7, toolbox, enter, move across, divided by 5, toolbox, the factorial is there for us straight away, enter, that's what we want, 42. If they'd have asked us to list all the possible arrangements, there would have been 42 of them. B3. Calculate the probability that chosen at random, Tess organises the lab. So chosen at random out of all the possible teams, there are 42 of them, how many did Tess organise the labs? It's all of those. 1, 2, 3, 4, 5, 6. So it is 6 out of 42 where Tess organises the lab. Calculator, 6 divided by 42, 0.143. If we wanted a decimal, 0.143. What's the probability that, chosen at random, Tess is not involved in the team? Well, she is involved, we worked it out just now, in 12 teams. So therefore, 42 minus 12 says 30 where she isn't. So as a probability, 30 of the teams out of 42, 30 divided by 42, and we get 0.714 as a decimal. All right, in another classroom, 8 students are available. Calculate the number of arrangements if there are 2 distinct roles. So this is 2 roles from 8. So with our permutation formula, it's 8 over 8 minus 2, 8 factorial over 6 factorial, which is going to be 8. Choose factorial, move across, divided by 6. Toolbox, choose factorial, and we get 56. So if you're taking 2 people out of 8, there would be 56. What about 3 distinct roles? So we've got 3 roles from our 8. 8 over 8 minus 3. So that's 8. Obviously these are factorials over 5 factorial equals 8. Choose factorial, move across, divided by 5. Toolbox, select factorials, 336. So if you've got 8 students to take 3 distinct roles, there are far more ways. We have 336 arrangements.